Welcome to Decentralized Wireless Technology by Bleed.io Tech. Over the next few minutes, we will introduce and uncover the transformative impact of decentralized networks, vastly improving resilience, effectiveness in command and control, sensing systems, and overall connectivity performance. A review of recent Department of Defense solicitations and subsequent interviews with staff reveals that the need for alternative wireless technologies is widespread and growing. It's coming from ship decks, contested battlefields, and of course leadership, and the scope includes data sensors and security and more. The problem is, wireless communication needs in warfighting have far surpassed current capabilities. Today's state-of-the-art includes known technologies like Wi-Fi, Li-Fi, cellular, and even non-human sound spectrums, and more. Whether it's congested wireless spaces, the need for line of sight, poor environmental conditions, or dense and rugged terrain, none of today's state-of-the-art technologies have worked as needed. All options still suffer from fundamental challenges like resiliency, range, reliability, and security. Currently, we are developing edge-based, decentralized wireless technology and select hardware to solve the same long-standing wireless problems for commercial users, while at the same time identifying and implementing new applications never thought possible. Our SaaS and hardware leverage Bluetooth mesh, upon which we build device-to-device networks without the need for connectivity. Right now, warfighters are leaving powerful, next-generation wireless capabilities on the bench and compromising data collection, safety, dominance, and all missions. Standing in the way of next-generation wireless for warfighting are existing, centralized, infrastructure-based networks and their limitations and hardware challenges, like dated sensor and antenna technologies. As a result, wireless technology is a significantly underutilized resource in warfighting. Our approach to advancing state-of-the-art involves leveraging this novel mesh technology to address known failures and advance needed applications, while providing a platform for ongoing wireless innovation. The attributes of these decentralized networks, hubless, on the edge, peer-to-peer, address single point of failure risk and solve for reliability and resiliency. Operating without any central connectivity, these networks of nodes self-route and self-heal, ensuring no interruptions so that critical jobs get done. These networks are closed, AES 256, military-grade secure, which solves for the ongoing security concerns related to centralized networks. In developing software and hardware for these mesh networks, we have unlocked attributes like network portability, scalability, auto-configuration, and interoperability, all in support of known and needed next-generation applications. Imagine the ability to deliver an active network of war-fighting assets into any environment without the need for central connectivity. Thanks to auto-configuration and interoperability, select nodes are immediately assigned to their select network, including the reactivation of legacy hardware. Now warfighters can enter a contested environment, and they, their gear, and so on, will instantly join the appropriate network. Self-routing technology and high node capacity, up to 32,000 per each network, can address communications needs in dense areas or across vast landscapes. One example of how our platform can support innovation is that our technology will significantly transform drone swarm effectiveness. Operating without centralized control, meshed swarms interoperate, manage proximity, and most importantly, maintain mission objectives at the network level. Members of the Bleed.io team exhibit acknowledged expertise, a history of growth outcomes, and broad industry recognition. Perhaps the most obvious example of the it factor is this team is the only one of which we are aware to figure out and unlock this valuable, purpose-built, but complicated standard. Bluetooth mesh was launched by the Special Interest Group way back in 2018. The absence of meaningful development by any other organization speaks to its complexity and the need for experts' attention. Our traction on the commercial side, with a production version in place with several users, would not have been possible in so short a time without an outlier set of leaders managing timelines, resources, and customer needs. So what is the so what? Our commercial applications range from pedestrian and vehicular monitoring for smart cities and event managers looking to understand and optimize attendee flow and engagement, to first responders arriving on scene with their own decentralized communication network, and energy companies looking to secure, track, and monitor inventories, personnel, and safe practices. We see several defense applications, including the previously mentioned decentralization of drone swarms. We have seen ship deck communications continue to challenge sailors and put them at risk. A decentralized, self-routing, closed but scalable network can provide much-needed connectivity across vast deck expanses and levels. Smart bases would be significantly improved in terms of security, reliability, interoperability, and scale. The wireless transmission of telemetry for vehicles, equipment, environments, and warfighters can leverage a closed mesh network to avoid breaches and improve speed and reliability. In addition to AES-256 Secure, these networks employ real-time data transfer using efficient generic attribute profile APIs to facilitate low-latency, secure communication between devices. And while Bluetooth mesh does emit RF radiation, it operates within the 2.4 GHz ISM band and does not pose a significant hazard of electromagnetic radiation to ordnance due to the low power levels it emits. We are proud to share our innovation, and we thank you for your time and consideration.